I will be moving through this right here. This is vr.vex.com. You can see that up in the URL. I will also be switching through this right here. Now this might look a little different from the one that you see on Canvas. This is from my PLTW, straight from that website. So you'll have to see where I'm looking at here and kind of show this is a little bit better platform to look at it. Not all of you might be able to get to this, so just wanted you to see this. This is what I'm looking at. So I'll just go through the procedure on this, and you can follow along if you'd like, or you can try to accomplish it yourself. But let's get started. So move that here. I guess I'll go through the whole thing. So we'll look at some of the steps. It says, develop an algorithm, step-by-step process for solving a problem. Analyze and describe an algorithm represented as a flowchart or as programming code. Identify, test, and implement possible solutions to a problem using a computer. Create a computer program to implement an algorithm, including conditional statements and iterations. Okay, so one of the most powerful attributes of a computer program is its ability to make decisions. Although it can be argued that only humans are capable of decision making, computers are able to make decisions using criteria. They are able to compare two values and determine whether one is larger than the other. They can determine whether a statement is true or false based on empirical data. Okay, so this is the VEX code VR. This is the same URL that we just looked at when this video started. Here's the procedure. So in the programming world, and especially every time I see this right here, I'm going to say bot, because this is a virtual reality self-driving vehicle. I don't want to have to say that every time. So in the bot world, sometimes you want to have a program to do something forever, like wait for some input. Humans do this when we listen for a phone call or text alert, or when we listen to our bodies for when it's time to eat. When you do something forever in a program, it's called an infinite loop. So here are two versions of an infinite loop. So you can see this right here. It's forever. It just says forever there, and whatever's happening inside of this will happen forever. And also there's a while loop here. Now we call this a while loop, but it's a conditional while loop. And you can see that the condition is while 1 equals 1. It's like, okay, that's always going to be true, so this while loop is always going to happen. All right. I think that's basically what it's saying right here. Does have while keyword, and like it says an expression that evaluates true or false. So while something is true or false, this is the code, possible multiple lines that will repeat. Okay. So while this is true or false, code will always happen. You will use we're talking about while loops. You will use loops to help you knock down castles in the Castle Crasher playground. So when we go to vr.vex.com, right here, you can click on that as well, or in your assignment. Navigate to this and open the Castle Crasher playground. Let's do that first. So I'm here. I'm going up to playground. Click on it. And it's loading the grid map, but I want to load the Castle Crasher right here. Let's see if we can get that loaded up. There we go. Might take a little second here. Okay, while that loads up, we'll see what's next. Observe the playground layout in 3D mode and evaluate it to determine what sensors you might use in an algorithm to help you find and knock down the castles without driving over the edge of the playground. Explore the sensor blocks in VEX code you may not have used yet. Compare and contrast your evaluation of potential sensor use. Okay. Check all the ways that could keep the bot from driving over the edge. So let's look at this before we go back. So what are some ways we can keep the bot from driving over the edge? So you have a Castle Crasher playground. If we look at this, I will expand it out a little bit. And they're saying look at it in 3D view right here. There is nothing stopping me from driving off the edge of this. That is not a wall, that red area, that is the border. So it is red. It is important to note that for these questions coming up. I want to knock down these castles. All right. So check all the ways that can keep the bot from driving over the edge. Let's see, an algorithm could look for red with the down eye and turn when it detects red. Now, that's definitely a way. An algorithm could look for red with the front eye and turn when it detects red. Not sure if the front eye is going to pick up what's on the ground there, so no. An algorithm could track the grid coordinates of the bot and make it turn around if it is out of a certain range. That's true too. Let's see if we're right here. I don't know. Let's move ahead. Check all the ways that check all ways that could be used to find castles. Okay, well, these are what the castles look like. There's a green one over there. Let's see if it will work. While loops could be used with the distance sensor to determine if there is an object in front of the bot. Okay, I think that's probably true. A condition can be used to perform certain actions if a left or right bumper is pressed. A condition can be used to perform certain actions if a left or right bumper is pressed. Okay. A condition can be used to perform certain actions if a color is sensed. I think that's true too. Let's submit and see. Oh, all right. So I missed this one here. Check all the ways that I guess I checked a condition can be used to perform certain actions if a color is sensed. I thought that would be true based on the color of the castle there. Guess not. I guess they're saying no. So this is a hint anyway of maybe of the ways you can keep your bot from not falling off the edge right here. Hey, we can use the algorithms to look at the ground. An algorithm could be track the grid coordinates of the bot and make it turn around if it's at a certain range. And then there's some while loops or condition for bumpers and distance sensors. Okay. Many programming challenges have multiple solutions. The more sensors there are, the more ways that a challenge can be approached. You will be guided on one solution, then have the opportunity to improve your solution or try different solutions with other sensors. So we'll make one and you have the opportunity to make your own or additional support for that one. So here we go. So from the control block section, add a forever loop to when started block. Then add a while loop to the forevers code section. So if you're like, what does that mean? You can always click this and it gives you the picture. So it's like giving you the answer right here. All right. So I'll go back and I'll say, well, I want to move this out of the way. And I'm going to go to control, you see, and bring a forever loop in here. And also bring a while loop inside of that forever loop. Okay, that's what it said. So nested. Nested is inside. When I say nested or inside, that's what it means. You will use a new section in the code menu called operators. Drag out the not block. This block is used in conditionals to get the opposite of whatever is put inside it. Okay, so it's not this thing. So from the sensor code menu, add the down eye detects red block and place it inside the not block. All right, let's take a look. So operators, and there's a not. Now this is a very simple explanation of saying like false. This thing is false. So this thing is not happening. And they put the not what? The sensor down the eye detecting red. Okay. So the down eye detects red, as it says here. Can anyone take a guess at this moment what that is going to be doing? Just think about it for a second. Okay. In your notebook, write an equivalent to the code shown in figure 3 as natural language and pseudocode. You don't necessarily have to do this, but what it looks like would be natural language would be something like, if the down eye does not detect red, pseudocode opposite of down eye detects red. Notice how natural language is something like something you would say more, whereas pseudocode kind of is a mediator between the actual code and the natural language, where it's like, okay, it's not exactly code, it's not exactly natural language, it's kind of a little bit of both. So the opposite of down eye detects red. See how that works? Okay, 8. Place the not down eye detects red block inside the while loop. Oh, I think we already did that. So, oops, it's just right here. So it's place the not down eye detects red block inside the while loop. Okay, I think we already did that. Yep. Check all the statements that are true about the while loop. So the while loop will continue until the down eye detects red. So let's take a look at the code. While this is not true, this condition happens. As soon as that is true, what happens? So while the loop continues, the while loop will continue until the down eye detects red. The while loop will end when the down eye does not detect red. The while loop, that's actually a good one. This while loop's happening, and when it detects red, it won't happen. So you see, the while loop will continue until down eye detects red. The while loop will end when the down eye does not detect red. No. While the loop will continue, the while loop will continue until the down eye does not detect red. The while loop will end when the down eye detects red. I think those are what will happen. Let's see. Yeah, okay. Add and move robot pen down block to track the path of the VR bot. So add, and move robot pen down block to track the path of the robot. All right, so what that looks like is over here in looks, there is a robot pen down. I'll move that right here. And now the robot pen will start right at the beginning and just remain down. And we'll see if that'll be enough. It says create a flowchart of an algorithm to move bot inside the red playground boundary and then program your algorithm. Do not worry about hitting all the castles yet. Just make sure the bot cannot drive outside of the playground. It just says create a flowchart of an algorithm. So you could draw a flowchart and it would be like a, hey, when the bot, drive forward, make right turn, does the bot detect red? No, okay, keep going. Does the bot detect red? Yes, but no, stop robot or turn around or something like that. So now we've done some while loops and we're going to do an if statement. And this is a little bit different than the if then statement, which is if this, then this happens. This is an if else statement. It's just like an if then statement, but it adds one additional element. So here you go. You have previously used if-then statements to execute code when a condition is true. The if-then statement can expand to include code for when a condition is false. This is called else clause. The else clause serves as a catch-all when no other condition is met. Okay, so it's like, what is this? If a condition is true, then the code below the if will execute. Otherwise, else the code below else will execute. This is a lot more usable than the if then statement because what this gives you is a way to do an if then statement without necessarily having to nest it inside of a loop. Because what you can say is, hey, if this is true, then do this. But if it's not true, then just keep doing this down here. Something I always use for an if else statement would be a light bulb, okay, like a light bulb and a switch. Hey, if the light bulb's off, or if the switch is off, then don't do anything. Anything else, turn the light bulb on. It's kind of an interesting way to think about it. If the switch is equal to false, so if not, the switch is on, whatever, then they'll do nothing. Light will not turn on. Okay? Light and the switch. If the switch is on, if anything else but the switch being off, the light should turn on. That's a one way to do it. Okay, 11. You will use the following if then else statement to crash into all the castles. Translate this block into natural language and pseudocode. So we have an if statement. And then it has these parts where it's like, write it in natural language. You can do that if you wanted to, if you were in POE, but we're not going to do that here. We'll worry about it now. But you can do it. But this is not something you have to turn in. It is probably important to practice. So if the distance found an object, meaning the distance sensor found an object, drive forward. Else, turn right for 5 degrees. So what are you doing here? You're looking. I'm the robot. My eyes are looking. If there's something in front of me, drive forward. If not, 5 degrees. 5 degrees. Until I find something, right? And when I find that something, when that if statement is true, then I drive forward. Knock it down. All right. So it says you will use the following if-else statement to crash into all the castles, translate these blocks into natural language. Where does that fall into my program? So let's take a look. While this is not happening, we can put an if-else statement. So right here, if-else. By sensing I, make sure I find the distance sensor here. Distance found an object. Then what will happen? Drive forward. Else turn something degrees right. Is that what it said? That was 5 degrees. I believe when we confirm that, yeah, turn right for 5 degrees. Okay. There you go. Why do you suppose a value of 5 is used? Do you think other values might work? Sure. But probably don't want to overdo it because then you totally miss. So add an if then else statement to the code so that your bot will seek out castles to crash without driving over the edge. Consider what the code is doing and best place for it. Maybe you already did that. Continue to iterate your program until your bot meets the objective to crash through all of the castles without falling off the edge of the field. Download and save your code. Okay, is your bot driving around the playground an example of a closed loop or an open loop system? It's a good question. So my bot's driving around. Is it open loop or closed loop? We talked about this. An open loop would be something that doesn't receive feedback to make an alteration to the code, so to the original objective. But because we have sensors on this, I would call it a closed loop because it's doing something until it gets a sensor reading, then it's doing something else. So I'm going to say closed loop. Let's check our answer. Yeah. All right, we're almost done here. Maybe we should run our program and see what happens. But first, let's just see if we can do it. Combining conditionals. Actually, let's run our program just for fun. Let's see what happens. So we have this program right here. I'm going to put at the end of the loop, we're just going to stop driving. But really, that's never going to, it's always going to be the case. So let's just take a look. Knocking the castles down the door. Oh, we have something on edge. Reset. Let's see what happened in the top. It just drove. It drove the castle, pushed the castle. The bottom red should have happened. It should have done something there. Oh, you know what? It fell off the edge. It was trying to do something, but it fell off the edge. It was turning to the right. I believe if you look at it, one more little observation here. If you look at it right here, it's trying to turn at the end, and I don't think that's a sensor turn, and as soon as it turns, it falls off. So we have to do something about that. All right, let's move on. You learned earlier that there can be different solutions to a problem. In this part of the activity, you will explore another solution to the Castle Crasher program. Review your existing program and consider what the while and if statements are doing. If you state their purpose using natural language acting as a robot, you might say, while I don't see red, if I see a distance object, blah. Natural language gives you a clue to an alternate way to write the program. The statement, while I don't see red, if I see a distance object, has an important feature, the conjunction. The statement combines two conditionals. In a programming languages, you can test the combinations of conditionals using Boolean operators. The name Boolean comes from mathematician James Boole, who wrote Algebraic Laws of Logic. So Boolean operators are and, or, and not. Operators are and, or, and not. And, or, and not. Find and review the Boolean operators in the operating section of the code menu. So we have and or not. The and operator tests whether two conditions are true. The or tests whether either of two conditions is true. Finally, you have already used the last Boolean operator, not, that tests if a condition is false. You will use these Boolean operators in a new version of your program. Create a copy of your code to modify. So drag your solution away from the when started block. Duplicate all of your code and drag the copy back to when started. Okay. Drag your solution away from when started block and duplicate all your code and drag the copy back to started. Okay. So it's saying go like this. Come on, drag all that away. I think I can duplicate it and place that there and just pull this one back in there. I think they don't want you to mess that up and lose it. So I just right clicked and duplicated it. All right. Modify your code so that it implements the following pseudocode. While not detecting red and found a distance object, drive forward. If detecting red, then turn right. Test your program if it is correct when it crashes through the castles. It is correct when it crashes through the castles. Okay. So I have a little bit more. That's it. Okay, so this would say, while not detecting red and found a distance object, drive forward. Let's take a look at what that means. So, while not and maybe we should put an operator in here that is, can I do it like that? Let me see the sensor here. Here and down. While not and what? And while not detecting red and found a distance object, drive forward. So one of them is true and one of them is false. So is this the right one? It says test whether two conditions are true. The or test whether either condition is true. finally, test is not. Let's take a look. I think instead of doing it like that, we should flip two things around. So instead of putting that one inside the knot, I think we should have this one down here while this condition is happening. The down, or not the down eye, the front eye. I don't know why I'm saying front eye. Actually, shouldn't be that at all. My bad. And this is kind of getting in the way. So while what? While I found the distance here and not down eye detects red. Oops. So while the distance found an object, so the distance sensor found an object, and there's not a down eye facing red, then drive forward. Now, this one doesn't have, it didn't say in the pseudocode to, well, it says drive forward if detecting red, then turn right. Oh, I guess that's for a little bit later, right? Is that right now? So when your code is blah, 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 while not detecting red and found distance sensor, drive forward. If detecting red, then turn right. Okay, so I wonder if this is going to work. Because it says this, it says while the distance, like there's something in there and I'm not red, then repeat this loop. And the loop is, if there's down eye, text red, turn right 5 degrees. If not, drive forward. So I think I might have messed up something here because I want to do while not detecting red and found object, you found the object, drive forward. If detecting red, then turn right. Test your program is correct when it crashes through the castles. Let's take a look. And maybe I don't want it to turn right in certain degrees. Maybe I want it to turn right, like not scanning, but just actually turn right. My only concern is this one. Well, that's actually going to work, I think. Because the thing that saves it is that it's in this forever loop. So this is still continuing on. So let's take a look at this. I'll play it from above. So it's going to crash into this castles, hopefully. And then it should do something when it hits the red. Now, if it was, oh, and I can see what's active, so, and not down eye detects red. Let's try that one more time here and see if I have a different view of it when I go like this. And I can see some of the stuff up here. Didn't detect red, didn't end up doing anything though. It says if it detects red, then turn right, else drive forward. Blasted. So both of these have problems in it. I guess we'll have to try to fix them. It says you now have two versions of the Castle Crash program. Well, both not working. You may prefer one over the other, and programmers can debate which solutions they think is better. What they think aren't better. But both are valid solutions to the problem of the Castle Crash. Not really. Now that your bot is moving forward the playground, the focus shifts to whether the algorithm is efficient. Using the distance sensor as input helps the bot target The structures helps target where the structures are without having to program every single castle location. Consider how efficient the algorithm is. To measure its efficiency, you can add code to see how long it takes the bot to knock down the castle. So inside the forever loop, I can add a print block. In place of hello text, add a timer in seconds block from the sensor code menu. Okay, so it says I can add a print block. The print blocks are going to be in the look section, I believe. And it says instead of hello, I can add a timer. It says in place of the hello text, add a timer in seconds block from the sensor code menu. Oh gosh, okay, so sensor code, timer in seconds. So hello there. There we go. Open the monitor panel and run the program from the beginning. Determine why the output looks the way it does. Look through the available code blocks and determine a way to make the output easier to understand. What? Okay, so it says different solutions are possible. Some include one or more of the following blocks. So set cursor to next row, clear all rows. You can test and compare the efficiency and variations to your algorithm, experiment the turn right values, and observe changes in efficiency of crashing the castle. Open the dynamic castle crasher playground. Consider how efficiently your program crashes randomly placed castles. Download and save your program. It's the dynamic one changes the castle locations, by the way. Be sure to screen capture or download the text output too. So this right here is what you submit. You do a screen capture of your program. You'd answer these questions here, and that's what you actually submit. You want to also try to be effective with this thing. So let's change this to not to turn right, but a turn right for a certain distance and see if we have better outcome here. All right, let's play it. I wonder if I don't get to play around. I hope this works. All right, let's run our program now. Let's run our program now. I'm crashing through from the top. What's going to happen? It's falling into the abyss. What can we do? Let's try it again. Let's look at it and troubleshoot. So how do you troubleshoot this thing? Well, it helps when I press play here. When I reset and press play, it actually tells me what's going on. It's driving forward. It's driving forward. So it is working because it is driving forward. What happens here? So it does activate the while loop. So distance found, while the distance found and red, I'm not red, and run this right here. I don't know. Let's see. I got rid of the not, and I put the sensor here for the red, right here. I did do a down eye, and I said detects red. Let's see if it will do anything. Huh. It's not doing anything. Why? Because it's, hey, I'm not detecting red. So while the distance found and not red, if the down eye detects red, then turn right 90 degrees. Basically, it's on this while loop right here. And it's not moving at all. Because one of these things is not true. Okay? Down eye is not detecting red. And it says it has to detect red for it to actually be active. So we have to put a not in there for that. Or we might not need this at all. All right, so I want you to play around with this program, see what's going on here. Let's see if this guy works. There we go. Only thing is it didn't keep going, so the distance not finding an object. So there needs to be another thing in there that says, hey, so right now it's waiting for an input. And it's not going to get an input because nothing else is actually moving. So I need it to say, hey, you know, this is happening right here that prevents it from falling off the edge. Now, can I concisely make another one? I could, yeah, I can do another if statement that says, an if else statement that says, hey, also, additionally, if I don't detect something, if I'm not, just like before, not detecting distance object, just like before. And again, this is probably not the most concise way to do it, but it's okay to do this. And it's just the same thing I'm going to write down there. So I'm going to do, hey, if I'm not detecting something, or if I'm detecting some object drive forward, not, and these might be contradictory. Like this. And a lot of times, if something can be concise, if I have two drive forwards here in loops, it's probably a better way to write it. So let me see. I'm going to write, do the 5-degree thing. All right, here we go. Let's see if our robot does any castle crashing. Okay, so it's activated through the if statement. It is driving forward. I am finding an object. I'm turning, and I want it to continue driving forward. So if I'm detecting an object drive forward, if not, turn 5 degrees. Now it should be right here. The problem is this while loop is dependent on me having something in front of it. So what's going on? Okay, one last thing, we'll see, and then I want you to try it on your own. I'm going to put a knot in there, and let's see if something happens. Probably something terrible. Let's take a look. Probably goes back to the end. All right. I'm doing this, nothing's happening. Why is that? Because I'm sitting on a while loop, and it won't do what's in the while loop until that condition is met. So right now, I am detecting something in front of me, so it cannot be this. I think we're on the right path, and I think that makes sense that they'd want to something to be one of these Boolean things, like, hey, while this and this, or this, one of these things on this thing. What about an infinite loop? What do you mean, Mr. White? What if I did while a 1 equals 1 here? Real quickly, hey, I'm running this while loop. What's happening here? I'm driving forward, hitting this thing forward. I'm crashing these castles. I'm doing a great job. Kind of stuck there, it looks like. I wonder if it'll get itself out of there. Why is it stuck? It's always kind of fun to understand why it might be stuck. Got stuck for a second. It'll go back around. Needs to knock that castle all the way down. Huh. All right, so I think it just knocked down all the castles and achieved its objective. I guess there's one more, but you saw what happened here. You saw what I did, I believe. Oh, right here. Really, the way that it's written, that I wrote it down, is not very efficient because this while loop is within a forever loop, so that's actually not even needed. Like I could probably go like this and pull that out, put these if statements in here, and if that's the case, then that means that Um, these could be written even more efficiently. Like, hey, drive forward here. And that doesn't say it's right. I'm not saying what I'm going to do is right if you mess around with this, but I think you can tinker enough to get it correct. Let me see two things when you do a screenshot. So make sure you do a screenshot of your code and also do a screenshot of your path at your robot. So that end image that I should have done when I play this guy. And after it's all done, I want to see that path. I want to see it actually do it. So I must only see something that's a certain distance away from it. Oh, look, it's like, shh, shh, don't say anything. I want to get that one now. Man. So at the end of this, when I stop it, you can take a screenshot of this. So you can probably do two if you want to, two screenshots, or you can do one with both of them in it. Two screenshots is good. I use the snipping tool. You can go down to the bottom left corner, click on the Windows, and start typing snipping, and you should see something like this come up. When I go to snipping tool, and this might freeze me, by the way, but I can click new, and then I can make a box over my screen, and then it'll save it as a picture. So I can go new, make a box over my screen, save this as a picture. This wouldn't be great because it doesn't have the whole path of the robot on there, but try to get this thing completed and submitted.